Welcome to qnawire.
Hello everyone, in this question we will learn about some basic concepts of the chemical reaction. The question is propane is burned with 30% excess air. We have to determine the mole fractions of each of the product. Also we have to calculate the mass of the water in the product per unit mass of the fuel and the air fuel ratio, right? To solve this question we will write the general form of the chemical reaction. So in this case, the general form of the chemical reaction would be C3H8 plus 1.3A O2 plus 3.76 nitrogen. This will give the products. So here there is 30% excess air that we have assumed plus 3.76 D nitrogen. So when we solve this and we do the analysis of the components, we get the coefficients as A equals to 5, B equals to 3, C equals to 4, and D equals to 6.5. Therefore, the final reaction that takes place would be C3H8 plus 6.5 oxygen plus 24.44 nitrogen. This will give the product as 3CO2 plus 4H2O plus 1.5 oxygen plus 24.44 nitrogen, right? Now the next step is to find the mole fractions of each product. These can be determined from their mole numbers and the total mole numbers. So the mole numbers, the mole fraction of CO2 would be equal to 3 divided by 3 plus 4 plus 1.5 plus 24.44, that would be equal to 0.091. Similarly, we can find the mole fractions of H2O, that comes out to be 0.121. The mole fractions of oxygen and nitrogens will come out to be 0.046 and 0.742. Now the ratio of the mass of the water and the mass of the fuel is determined by their moles number. Therefore, the mole numbers of H2O divided by the mole number of propane, 18 multiplied by 4 divided by 1 multiplied by 44.097. This will give the ratio of mass of the water and the mass of the fuel. So that comes out to be 1.63 kg of H2O per unit kg of fuel. And this is also known as the air fuel ratio. Sorry, this is the ratio of water and the mass of the fuel. Now the air fuel ratio is determined by the mole numbers of nitrogen, oxygen and propane. So the air fuel ratio would be equal to, this is the mass of nitrogen plus the mass of oxygen, that would be 32 multiplied by 6.5 divided by the mass of the fuel, that would be equal to 1 multiplied by 44.097, that comes out to be 20.2 kg air per kg of fuel, right? This is the air fuel ratio.